Okay, so as we talked about at the very beginning, talking about the properties of amines, amines are bases. They like to deprotonate things or to steal hydrogens away from acidic molecules. So we did an ionization reaction with carboxylic acids where when we mix carboxylic acids with water, we have an equilibrium where that hydrogen is removed. Well, now that we're having a base instead of an acid, we're going to do the same ionization. However, it's going to be the opposite. So now if we have our base, which in this case, I'm just going to give you ammonia as the example, and we have that in water, it's going to be in equilibrium. You can keep the red. In equilibrium in a state where the nitrogen has stolen the hydrogen, one of the hydrogens from water. So now nitrogen is going to have four hydrogens in this case, or four covalent bonds. And now because it does have four covalent bonds, it's going to have a positive charge. If you do your formal charge counting for this, it would have a formal charge of +1. And then you'll also have, really, in reality, it's more, they're kind of connected because they're a pair. And then you'll also be left over with OH minus. So always want to balance out those charges. You steal just the proton and leave the electrons to the oxygen. So another example of this, let's say you have groups on the amine. How would that look? We're going to keep the amine, I said imine. We're going to keep the amine the exact same, except now we are stealing one of the hydrogens away from water, giving ourselves a positive charge, and we have OH minus as our result. These particular functional groups that we're making are called ammonium ions. So the specific name of this first one is really just ammonium ion because we're taking ammonia and making it into its ionic form. But now we need to learn how to name that ion form of other things too. And all we do is replace amine with ammonium ion. So for this example, we would have diethyl ammonium ion is the name for this particular, the nitrogen parts of that. The nitrogen with the positive charge, that's an ammonium ion. Okay, so that is what happens when ammonia or amine is in water. But what happens if the amine is with an acid? So instead of making an ammonium ion and ionizing in that way and having that equilibrium, now we're going to do a full-blown acid-base reaction or a neutralization. So we're going to neutralize the basicity of your amine through adding an acid. So if I take my amine and add HCl, which is a strong acid, I'm going to make an ammonium salt out of that. So overall, a very similar thing happens in that your nitrogen stays pretty much the same, but now it steals one of the hydrogen or the hydrogen from the acid, gets that positive charge again, and then your counter ion is going to be whatever was your like halogen, for example, on the other side, or on the bottom, you'll see with carboxylic acid, it's a little bit different. So this is now a salt because you have a positive and negative charge. They interact together, kind of like sodium chloride, that inorganic kind of molecule. This is an organic-y form of a salt. And to name this, now we're going to replace, instead of having ammonium ion replacing amine, we're going to have ammonium, and then the X here stands for whatever the counter ion is. So in this case, we had methylamine. So to name the ammonium salt of that, we're going to have methyl ammonium and then I don't have enough room, so let's try this again. Oh no. Methyl ammonium, and then chloride, to show specifically that we had a chlorine as our counter ion. So to do this, we don't have to only use like HCl, HBr, stuff like that. We can use a carboxylic acid as well. So we can mix together methylamine and acetic acid, and the same reaction will occur. Our amine is going to steal away a hydrogen, and now we're just going to have a different kind of salt, just different components incorporated. So draw out the same amine, add a proton to it with a positive charge, and then this is the proton we're stealing, so we're going to draw the rest of that acid, carboxylic acid, but now in its carboxylate form, because it has to have a negative charge since we stole that hydrogen. So the name of this is going to be the same thing, ammonium, and then now you're just, instead of X, you're going to be putting what your counter ion is, which we know from our naming of our carboxylates. That's how you're going to name it. So we have methylamine. The first part here, it was methylamine. So now we're going to change that to methyl ammonium. And then our counter ion, the negative part, is going to be the carboxylate name. So we started with acetic acid. So we get rid of ic acid and add ATE, so acetate is the answer. Okay, so let's do a couple practice problems. Predict the product of the following reactions and name the product. Feel free to pause the video now and try it on your own, and I'm going to go through the answers. Okay, so this first reaction is a neutralization just with water. I'm sorry, an ionization just with water, this equilibrium process. So I'm going to draw my same amine, add my hydrogen and put my positive charge. And then with that, I have my OH minus to show that I have the counter ion, I guess, necessary for that. Okay, and then the name of this. So we had over here, ethyl dimethyl amine. So in order to name our ammonium salt or ammonium ion, in this particular case, we're going to have that same name, ethyl dimethyl, and then put ammonium ion in replacement of amine. So that whole name there is the name of that product. Okay, so let's do another one. We have ethylamine here. Interacting with this carboxylic acid. So again, we're going to steal a hydrogen atom. Have a positive charge, and then we need our counter ion. So I'm going to draw it a little bit different to show those positive and negative charges as close as possible together. Okay, so we have ethylamine and then propionate. I'm sorry, not propionate, propionic acid. So again, we're going to start off with the positive part. So the ammonium is the first part we're going to talk about. So ethyl ammonium. And then name our negative part, which is going to be the propionic acid, but we drop the ic acid, add 8. So then we have propionate. Okay, and then continuing on to this last one. We have, so isopropyl dimethyl. So I think methyl comes first. So dimethyl isopropyl amine, or interacting with HBr, hydrobromic acid. Okay, so again, we're going to steal that hydrogen away. We'll draw the amine the same way as we did before. add our hydrogen and our positive charge, and then our counter ion is Br minus, because that's what we're left when we steal a hydrogen. So our name is going to be dimethyl propyl ammonium, and then our counter ion bromide. Okay, that is talking about the basicity of our amines and the reactions that you can, or the most simple reactions that you can do with those bases, those amine bases. And yeah, that's where we're at.